A school nurse records the height, all right, the height cm of each of the 150 students in a class A who was vaccinated. The table below shows the information. So we're seeing the information in the table, the different height of the persons and the number of students who were vaccinated. All right, it's in the column. So it is obviously there, you're looking at it. Let's jump to the table and see what we could do. It says, complete the table below and use the information to calculate an estimate of the mean. So we're going to be dealing with some mean here. The mean height, and give your answer to 1 dp. Well, this is actually one of the easiest mean question that they had asked. And the reason that I'm saying that is because they work out the problem for you already. They did all the calculations and they left 2 empty spots to be filled. Just one here and another one here. So we have 2 empty spots to be filled. 2. So because we have 2 empty spots to be filled, we're going to do it. Now, as you could see, mid value, we're talking about the midpoint here, middle. So you could see the middle here, that this middle was a 70, this middle was a 90, and you're seeing the numbers over here. So when we reach here, what's the middle here? This is 120, this is 140, the middle is 130, right? And the fact that I have the middle, which is the x, I can find f times x. So you take out your calculator and you're multiplying 67 times 130. So there goes 67 times 130, and you would have gotten 8,710. Now we have completed that, but remember they asked us to do the mean. What is the mean? This is 150, guys. All right, so this is the sum of the f. The sum of your frequency is 150. I need the sum of fx here, this column. So we're going to add up everything, add it up and go down. So what are we adding? We're adding 280 plus 1800 plus 3,850 plus 8,710 plus 3,000 plus 680. And then this would have given a total of 18,320. The mean is equal to the sum of fx over the sum of f, which is 18,320 over 150. And my answer that I'm getting here is 122.133. But remember, they gave a specific instruction, 1 decimal place. So then the answer is 122.1. So we have 122.1 going there. All right. Next question says, in class B, the mean height of the student is 123.5 and the standard deviation is 29.87. And that's so, and they're saying this is for class B. For class A, the standard deviation is this. It's a 1-mark question. And let me show you quickly what goes on. What we have is they put the mean in the middle here. All right, hold on. The mean is here. And we got the mean, say this is class A. The mean is, where is the mean for class A? Oh, we worked out the mean for class A. It was 122.1. The standard deviation is 21, which means that it goes down to here and come up to here. So it's like you subtract 21.38 from this and you add it to it to get 2 other kind of bar to show how the scores were spread out. So then, basically 122, you're not required to work this out really, no. I'm just doing it so that I can explain it to you. So this goes down to about 100.72. And then it would have gone up because I'm going to add the 21.38 to it. and it goes up to 143.48. This is suggesting that this is how far the scores are spreading from the mean. That's what the standard deviation tells. How far away? It's 21 point something to the left and 21 to the right. So majority of the scores were between that and that. That's what it is saying. Now, if I show you the other one, then I'm going to show you what you would have been required to say. All right, this is just to explain to you. So you learn something. This is where this mean is. It's 123. Now, 0.5. If we add 29.87 to it, it will go all the way up to 153.37. And if you subtract the 129 from the 29.87 from the 123.5, you're going to get, it's going to go down to 93.63. It is telling you that this is how the things were spread out, how far it is from this. Here's the deal. So this is situation B. You're seeing here, look at this number, 100, 140. They are closer to the mean. In this case, it is further. This is actually 123 and this is 90 something. And then this is 123, this is 150 something. So you could say that in class A, the scores are closer to the mean score. So generally the scores are closer to the mean score than class B. So class B, they are farther away from the mean. You could see it right there. The 153 to the 123 is a very bigger number compared to 143 to 122, the distance between. So that is all they wanted you to say right there, that the spread of the thing is closer in class A compared to that in class B. The spread of the scores. Next question. Complete the cumulative frequency table. Right? Complete the cumulative frequency table below and use the information to construct a cumulative frequency curve on the grid. All right. Remember the cumulative frequency curve. So this 4 will be there. Yeah. So you're going to add 4 to your 20. That's how you get 24. So you need to add 24 to 35 and then you'll get 59. If you add the 59 to the 67, you will see the 126. So you continue adding 126 to the 20, and then definitely this is 146. So there it is, we have 146 right there. So we complete that. It's only 2 little things they gave us. From that, they're asking us to now plot the cumulative frequency curve. We're just going to plot 35 with, not 35. We're going to plot 120 with 59 and 160 with 146. So those are what we're plotting. 120 with 59. So 120 goes up to 59. 59 is right in that empty spot right here. Right here. And then, so it is right here. And then what's the next one? 160 with 146. Following 160. So 160 is all the way out there, 146. All right, let me take off this. Oh, but I need a pen. All right. 160 with 146. 140, counting by 2, and 46 is right here. So what we're going to do is simply just draw this curve. So I'm going to try to draw this with my software here. Give me a second. Let me draw this. All right, hold on. All right, let me kind of fix this. All right, so we're looking for that sort of thing, right? That's not perfect, but you're looking for that. You just want to do that and you're good to go. So now, they now want us to use this to answer some questions. So here are the questions. Using your cumulative frequency curve, find an estimate of the mean. Remember, we did say that the mean is actually Q2, which is 50% of the sample. We're talking about 150. Let me look if it says 150. Yeah, it's 150. So half of 150, yeah, 75. So this is the marker that we're going to use at 75 to go across on our curve to pick up that value. So we're going to follow 75. 75 is halfway between 80 and 70. So picking up this line here, halfway is going to be right here, and I'm going there, right there. All right, when I blow this up, it's right on the first line to me. So I'm getting in on this line here. All right, so basically it's on that first line. And based on the scale, this is 130. So we're going by 2. So this response is 100. This is 122. I'm getting there. I'm getting 122 on that. So let me go back to the question here. It's a 1 mark, easy pickup. I'm getting 122 when I do that. The next question says the probability that a student chosen at random would be taller than 130. All we have to do is to find 130 on our grid, go up. So we're going to find 130 on the grid here. All right. So we're going to take out our thing. Here's our shape. 130 is right here. And right where it touches, yeah, it touches it right at 100. We bring it across. When it come across at 100 to me, that's what I get. So I'm seeing 100 there, right here. But that's not the answer because they said that the foot is bigger. Their height is bigger. So we're going over. So we want to go between this because you're talking about bigger than that 130. So then this answer here is saying 150 minus 100. So we only have 50 students in that category. But remember now, it's a probability question. So it's going to be, where's the question? Right here. It says the probability that a student chosen at random will be taller than 130. So we have 50 students out of 150. 15 to have 1, 15 to that 3. So if you want to write 130, you're correct. If you write 50 over 150, you're still correct. All right, so there we have that.